Alright guys, so in chapter 6 section 1 we're finding expected value, also known as the mean of our probability distribution table, and we'll also probably be looking at standard deviation. But let me show you how to do this on StatCrunch versus doing this formula. This formula just says I take each x value and multiply it by the probability. Well, we can get StatCrunch to do that for us. So when we're looking at our homework, let's open it up in StatCrunch. And if you have a TI, there's a way to do it on the TI. But again, most of us don't use TI. If you want to know how to do it on the TI, then let me know and I will make a video for you on that. So I want to find the mean of this. So I want to do summary statistics, but I also want to do it on a grouped bin data. So that's where I want to find my mean and standard deviation. I believe in chapter 2 or 3 we also use this. The one issue that StatCrunch is going to have is the fact that it has decimal numbers in here. So if we tried to do this and StatCrunch the way it is, we would get an error, I believe. The counts must all be integers. So what we need to do is we are going to cancel this stuff. In this column here, I want to make all these values integers. And to do that, I just need to multiply it by 10, 100, 1,000, 10,000. So to move my decimal 4 places, I would just need to multiply it by 10,000. So I'm going to go up to my var 3 and I'm going to compute an expression. This allows us to manipulate the data that we have. So I'm going to click build. I want to take my probabilities and I want to multiply them by 10,000. That'll move it 4 decimal places because I have 4 zeros. And now that I have that, I have integers. So that's what I'm going to do my grouped bin data on those integers, x and then the probability of x times 10,000, so that they're all integers. So now when I hit compute, I get my mean, right? My mean is 1.3852. That means for this particular question, this is the number of hits obtained in a game, right? The number of hits. So most players are going to, during a game, are going to get about 1.3852 hits. To 1 decimal place would be 1.4 hits. And it says, good job. And which of the following interpretations of the mean is correct? So we have to look at the verbiage of this. As the number of experiments increases, the mean of the observations will approach the mean of the random variable. That one looks pretty good. Observed value, I don't know anything about that. But as the number of experiments increases the mean, so that looks pretty good. Good. I miss those sometimes. The standard deviation we've already found. Like it's right here. 1 point to 1 decimal place would be 1.1. Right? And so again on this one we just went to StatCrunch and we had to create that extra column. We did that. Let's show again how we did that. We did that by going to the top and we went to data and we computed an expression. And the reason why we're building an expression, we took our probabilities that were decimal numbers and we wanted to make them integers. So we just multiplied them by the number that's going to make them all integers. So in 6.1 you need your probabilities to be integers. And it'll compute the values for you fantastically. Let's look at one other problem real quick. And so if you have an expected value here, you actually have to create your values. So on something like this, there is a net cost and then the probability of it happening. So let's look at this one real quick, and I'm going to go to StatCrunch. Let's look at it real quick. So a life insurance company sells $160,000 one-year term life insurance to a 23-year-old female for $370. The probability that the female survives the years is 0.999553. All right. So when we set this up, we're going to have her net and the net result, and then this will be our probabilities. So if you're doing something like this, you're either going to live or you die. If I live, which sounds like the correct path, I'm going to lose $370. So I'm going to put a negative in there. And I just want to verify that real quick. $370, right? Oh, it was there. $370. And the probability that I lose $370, right, means that I live is 0.9995533. 553. So that's the probability that I live. So let's go back to our StatCrunch. And the probability of that happening is 0.999553. All right. If I die, my net amount is not the 160,000 because I paid 370 yen. I paid 370 yen and my family would get back 160,000. So it would really be 159,630, the difference of 160,000 and 370. So 159,630. And the probability of that happening would be 1 minus this number. It's the complement. So I either live, which is that good number, or I die, which would be 0.000447. That should add up to 1. So again, if I want to find my expected value, I could just multiply these and then add them together, which is what the formula says. Take each x and multiply it by the probability, and then add them together. So that might be easiest on a small problem like this, or I could get StatCrunch to change it to an integer by taking my probabilities and this time multiplying by 1, 2, 3, 4, 5, 6 zeros. So that would be 1,000,000. 1, 2, 3, 4, 5, 6. And there's this new column, and now stat, summary stat, group bin data, my net values, and my probabilities times 1,000,000, so I get integers. Now I get a mean of $256, right? That's what this says. So my expected value should be 256. Let's look at the homework problem and verify to 2 decimal places. So that would be 256.27. Now, compute and interpret the expected value of this policy to the insurance company. So this may be a little incorrect. Let's hit a check answer. I think it's going to tell us we're wrong. Oh. So check answer, and it says, no, we're wrong, right? But it's in terms of the insurance company. So in the insurance company, they get $370, or they lose negative that amount of money. So if we compute this again, we're going to find out that it should just give us the opposite answer. But I imagine that's a mistake that you could have made, or something totally different. Let's see if I did that right again. So I go with stat, summary stat, group bin data, my net values, and my counts are there. Okay, the 405 seems wrong. I'm not going to make $405 per person. All right, so when we did this one, like this would be in regards to the insurance company. This is an issue with StatCrunch and how it doesn't read negative values. So when we computed this, we'd get an answer of the 405. It is not correct. And what I did is I ended up going to just a calculator and multiplied our values, 370 times 0.999553, and then negative this amount times the 0.000447, and that gave us what the correct answer would be. So in a problem like this, we cannot use StatCrunch with the negative values. So that's something that StatCrunch does not do. Let's check the answer. I got 298.48, and 298.48 is the right answer. So we have some limitations with StatCrunch that we're going to have to explore. So we will need the formula on a problem like that. Again, it's just a couple multiplications that we have to make. The main thing is you know how to make this table so we know what we're going to multiply. So this one's a little different since I have a negative amount in the net. So I hope that helps. It got me for a minute too.